Okay, maybe let's wait for 2 more minutes because
we got time. Yeah. I don't know what to do for the next, because I think at the next IETF we'll get more people here as well.
Yeah, it's also because it's Asia.
Yeah.
So a lot of North American people are not coming.
Yeah. Yeah, it's a really long trip. Especially the East Coast.
Some people from
crazy,
Ottawa.
24 hours or something.
25 hours,
yeah.
It's crazy.
There's nowhere ideal though, because if you do it in Hawaii or something, then it's 24 hours for us. Not quite. I mean, you connect to Vancouver, it's like 16 or 17, but still.
We need to go to Australia, so it will be far for everybody.
I know. We've done one in Australia for a really long time. Really, really long time. They should get one of those direct flights from London. They should do it in Perth. You get that 19-hour flight to Perth. They're up for doing an Australian one because they haven't done. It's been decades since they've done anything in Australia. They used to get these standards meetings on the Gold Coast or something. It's not that expensive to get to. It's not very environmentally friendly to get there. Probably.
Can we start now?
Yeah.
Okay, guys, it's time to start. This is a second session of BESS working group in Singapore. So this is a notewell. You probably have seen it multiple times already this week. But globally, it says that everything you say is just a contribution to the IETF community. Blue sheets are circulating. Please ensure that they are coming back to us at the end of the meeting. This is our agenda for today. And if you have any complaint, please raise it now. Otherwise, we will start. So, Sandy, you're the first speaker.
Okay, good afternoon. I'm Sandy Zhang from ZTE. This presentation is for EVPN ES failover use case, and we will use BFD for this use case. In this draft, we have co-author Yubao and Greg. So at first, let's see the problem statement. And as you will see, we'd like to monitor the link between PE1 and CE. Well, we know that in the normal situation, we suppose that CE is multi-homed to 2 PEs. So only 1 PE will be elected as DF and forward the BUM flow. So when in case of the link between PE1 and the CE failed, between the DF and the CE failed, we know that the second PE in this figure, we suppose that it's P2. P2 will take the charge of the forwarding BUM packet after it being elected as the DF. But we know that before it is elected as the DF, we have the time period for the BDP signaling. So PE1 will send the BGP packet to all the other PEs, and PE2 then started the the DF election function. So it takes time. So in order to improve the BAM packet lost, we'd like to use the mechanism defined in FC 5884. And we also use the subtool we defined in the existed working group draft, EVPN LSPP, to build the session between BDF and DF. So the follow is the procedure that can be used to build the BFD session between PE2 and PE1. In this figure, it means the BDF and the DF. So PE2 will send the request, BFD request to DF, and PE1 will acknowledge it and build the session between two PEs. So PE2 will monitor the link between PE1 and CE. Then DF, in this figure is PE1 will send the periodic BFD packet to PE2 to indicate that the link between PE1 and CE works normal. But in fact, the link between PE1 and CE failed. PE1 will send the BFD packet with the state set to admin down to PE2. So PE2 will know that the link between PE1 and CE has failed. So PE2 will elect it itself to be DF quickly and send the BAM packet. And also, if there's something wrong with the PE1, and the PE1 cannot send the periodic BFD packet to PE2, PE2 can also know the situation from the BFD periodic detection time, the BFD detection time. So PE2 will also note that there's something wrong with PE1, and the PE2 can also elect it itself to be DF and forward the BAM packet. This draft has been presented in progress meeting, and we received some comments from Ali. So it's very useful for us. So we add more detail about this solution to make it more clear. So we know that the DF will send periodic BFD packet to the BDF. So in default, the BFD multiplier, it means it will has relationship with the detection time. So the default value is 3. But if because this value can be configured, so if this value has been set too small, for example, you set it to 1, so 1 BFD packet lost may lead to the BFD switch over. So in the previous slides, only 1 BFD packet lost will lead to the PE2 elected itself to be DF. So in this situation, maybe P1 works normal. Now, then 2 PEs will all elected itself as DF and forwarding the duplicate flows. So this must be be paid more attention to, not to configure this value too small. And in terms of the BFD changes situation, because maybe we'll add some other router which can become the new BDF joins the network. The older BDF in this figure, we saw that it's P2. P2 is no longer the BDF anymore. So P2 must send the BFD packet, which the state is set to admin down to PE1 to make P1 to remove the BFD station. So the previous BFD station is no longer anymore. So, and when the new BDF send the BFD request to DF, a new BFD station will be built for it. So that's all the solution. Any comments?
Mankamna Misra from Cisco. So these BFD sessions are multi-hop BFD between PE1 and PE2.
Yes, between
And
PE.
what would happen if there is any issue between these hops and your BFD session goes down? Will both of them be active as a DF now and causing duplicate traffic?
You mean the first situation, duplicate DF?
Yeah.
Yes.
That,
Yes.
But that is worse.
Yeah, that's the worst use case for it. So you must pay attention to the value. You must set to the detection time to a reasonable value. And because we know that BFD session will be broken down due to some reasons. The first one is when you receive the BFD packet, which state is set to admin down. And the second is you have not received the BFD packet for a period of time. So as the period of time, it means the detection time. If you set the detection time too small, you will also lead to this situation. Yeah, duplicate packets for duplicate DF.
But if you keep timer, will it not be almost similar as BGP withdraws your route type 4 if ES is down? Like, are we really going to get anything much out of it using this multi-hop BFD? Just a thought.
Multi-hop BFD can be used in MVPN, but this means point to point.
I'll just respond. Yeah, go ahead. Okay, sorry.
Yeah.
Greg Mills, CZT. Well, first, you don't have to have multi-hop BFD. You can use MPLS LSP, and then it will be over tunnel. So, and you can construct your LSP over more secure domain of your network. So, to minimize. Yes, again, you're right. There is no way to differentiate whether path fails or the node fails. Right. That's a challenge, but that's the challenge with their any OEM fault failure management. So because we don't differentiate between path failure and node failure, but you can have some operational considerations that to make it path more secure, more stable. More stable, not secure, stable.
One question, speaking as working group member. So do you have one BFD session per ES?
Yes, one
Okay.
BFD session. Yeah.
Luc-André Burdet, Cisco. I just have a quick comment. There is a working group document that addresses DF fast recovery. So I would maybe invite you just to read that and see how it can be extended, or how BFD can be incorporated into that.
Okay.
Jorge Rabadan, Nokia. So I understand this is to speed up the DF election convergence, but in any case, in this diagram for PE3, you still rely on BGP to actually flush the max or switch the max to the other PE, right?
Yes.
So overall, for unicast traffic, you are not getting much out of this. For BAM traffic, yeah, you can get some, better convergence.
Yes, because we think it may take some more time for BGP advertisement for it. Yes, so we introduce the data plane detection function for it. Yeah, it's
Sure.
a data plane.
But coming
Yeah.
from PE3, you still rely on BGP.
Yeah, BGP also. P3 you should also know.
So a couple of comments on the multi-hop IP. Oh, Himanshu Shah. Sorry, Himanshu from Siena. So yeah, I think that the problem scope is it does exist, because if you are relying on the withdrawal of the ES route type 4, it will take some time for to kick the DF election and all that stuff. So if you have a BFD on multi-hop IP BFD, it can expedite that election. With respect to multi-hop IP BFD, you always have to keep a little bit longer time, because you need to have the IGP hill. Like he was saying, if you have an intermediate nodes that fail, your multi-hop IP BFD would fail as well. But that's always the hierarchical fault timers that you have to keep. You have to let the IPFRR and other stuff to take care of that. I think the second point I have is instead of doing this LSP ping to bootstrap the BFD, maybe ES route type 4 is a way to pass the discriminator between these multi-hop peers so that you can then do the BFD session, or maybe even seamless BFD. You can use those discriminators to instead of doing the explicit LSP ping for bootstrap.
If we use seamless BFD P2, in this figure, the BDF must send the periodic seamless BFD packet to detect if the link between P1 and CE looks normal. So it depends on the P2 send periodical, right? The periodically from the P2. So if P2 is configured that send the packet, for example, we send the packet every 60 seconds. It takes a long time, right? So we use the normal BFD session to detect the failure. It works more fast, right? Yeah.
It's Satya from Cisco. So I had the same thought like Hore. He just said, conceivably, if we have a BFD session between P1 and P3, then would that help? Like if the BFD, like your C to P1 link goes down, then you can convey the fact that it went down faster through BFD through to P3, and thereby you would get some speed up as compared to the mass withdraw, so that the routes at P3 will be switched to P2 faster. Would that work?
Yeah. BFD session is set between P1 and P2. So, but the monitor's target is the link between P1 and C. So we'd like to detect the failure fast, as soon as fast.
No, I understand. What I'm saying is, if you were to have a BFD session between P1 and P3.
If you have already a BFD session for it, yes, and but your discriminator may be different because we know the subtil V defined in EVPN RSP ping to start the BFD session, and the discriminator will be different from the other BFD session between P1 and P2. So it means different things. Yeah. So you will not confuse with it.
Okay.
Yeah.
I can talk to you offline.
Okay. Thank you.
AC Land of Cisco Systems. You could use both the IGPs advertise. I don't know what you said about seamless BFD, but that seems like it is a better solution. And both the IGPs include the advertisement of the discriminator.
Maybe.
Okay. Greg Mirsky, ZT. There is a problem with the seamless BFD because seamless BFD, you don't have expectation of the guaranteed failure time. You are dependent on the round trip time. And because if round trip time will be changing, that might affect your, basically you will get false negative. Okay, so the positive about methods that asynchronously independent set periodic messages, you can have a guarantee of when you do failure detection.
Okay.
Any other comment? So from a working group point of view, I would tend to encourage you also to look at the DF recovery draft to see if it's enough or if we need something else to add, but we need to find a common solution and not multiple solutions to address this problem.
Yes, can discuss with us. Okay. So
You're also the next one, I think.
Yeah. So the second presentation is for SRv6 inter-domain solution for VPN service. We have co-author Shaofu and Greg. So let me see this figure. It's a normal situation in the future network because we have not used SRv6 in our network now, but it may be not be any longer time and may take more time for it. So if we deploy different SR functions in different AS, it's a normal situation in future work because such as in the S1, we deploy SRv6 only, and we deploy SR-MPLS in S2 only. And for example, we suppose that the SBR1 can support SRv6 and SR-MPLS, but the SBR2 only support SR-MPLS. How to stitching the two network, the two AS to work together? So we find that if we can give the solution for it from the signaling control plane, and we can get the result from the data plane. So let's see the signaling control plane. So we suppose that if we'd like to advertise a route from CE1 to CE2, so when the route received by SBR1, SBR1 should assign a special MPLS label for the prefix received from PE1. We know that's the advertise function for procedure for it, right? So and when SBR2 received the special label, and it will make it treat it as the normal label and advertise in the S2 network, and so as well, and the C2 will receive the packet, receive the route. So, and for the other direction, we know that if we'd like to send the route from C2 to C1, so SBR2 will assign the label from, SBR2 will assign the normal label, but SBR1 will advertise this prefix to P1 and associate with the special SRv6 SID. So once the control plane finishes the advertisement, let's see the data plane. So if a packet, data flow packet, received from SBR1 from P1, the direction, from P1 direction. So SBR1 will recognize the special SID. So it will recognize it should be replaced with a label, with an label or a label stack, and forward it to SBR2. And in the reverse direction, the when SBR1 received the MPLS packet, we know that it means the packet is encapsulated with some top label, which is assigned by SBR1. SBR1 will recognize the special label and then replace the, we should call it, we remove the label and encapsulate the packet with the IPv6 packet. And maybe there's something SRH in it. So, and then SBR1 send the packet to S1. So in the two direction, the flow will only be treated on SBR1, and no anybody else, such as P1, SBR1, should know this function because this function has local significance. But the flow will be forwarded normal and received the destination. So it can resolve the hybrid network interconnection issue. So that's all I want to say today. Any comments?
Jorge Rabadan, Nokia. Is this intended to be also used for EVPN?
Yes, can also be used in VPN.
Okay, the draft seems to imply that the procedures are the same, but in EVPN, there are some specifics. Like the in EVPN, we use the argument part of the SID for things like E3 or for ESI filtering. So, you know, I think you should include procedures for that.
Yes, we should consider of it. Yeah.
Hi, Ketan Talaulikar, Cisco. There is a draft Agarwal Spring SRMPLS and SRv6 interworking, which you reference in your document as well.
Yeah, yes,
And
I
that covers not just the interworking between SRMPLS and SRv6, but also in across islands in a different format. So could you clarify what's new being added or specified here from the procedures?
Yes, we saw that draft, and we think that that draft gives the general consideration of the hybrid network interworking, right? So in this draft,
Because
we
the
specify the
procedures
detail. We specify the detail of this issue. So I think it has a relationship between the two drafts, and we focus on most details.
Okay, sure. I think we can take this offline, perhaps.
Okay, thank you.
Who's the next?
Thank you.
Jorge.
Good afternoon. My name is Jorge Rabadan, Nokia. This draft talks about some very small extensions for split horizon filtering and multi-homing, EVPN multi-homing. What do we mean by split horizon filtering? Well, in EVPN multi-homing, split horizon is basically the mechanism that is avoiding loops when you have all active multi-homing. For instance, if you look at the left-hand side of this slide, and you have an all-active Ethernet segment connected to CE2. When you send bump traffic from CE2, for instance, to PE1, and P1 floods that, the traffic goes back to PE2. If PE2 is the DF, you know, we want to really avoid the traffic coming back to the CE. So the mechanisms to avoid that coming back to the CE and to avoid the loop is what we know as the split horizon mechanism. There are two ways of doing it. The first one is the ESI label based split horizon type. And the second one is what we know as local bias split horizon type. So the first one relies on an ESI label. In other words, when CE2 again sends traffic, bump traffic to P1, P1 needs to insert an ESI label at the bottom of the stack that is identifying the source ESI. So when that gets to PE2, based on that ESI label, PE2 can filter and avoid sending the traffic back to CE2. Now, when you deal with IP tunnels where there are no labels, like for instance VXLAN or NVGRE, there's no labels that you can insert in the data path. So in that case, we use this local bias thing. Local bias basically refers to the fact that in the same situation, when CE2 sends bound traffic to P1, P1 will forward locally to all the local Ethernet segments. And when P1 sends the bump traffic to P2, P2 will actually filter traffic to all the local segments that are shared with P1. That is local bias. Now in the draft, we have a table with all the different encapsulations supported by EVPN, the default split horizon type, and whether they support either type. And in some cases, there is no choice. There is only one way of doing it. But in some encapsulations, you actually have the choice because you can support both types. So the idea with this draft is to add some very small extension. And in this way, basically, we signal the split horizon type that we want to use in a given Ethernet segment. The idea is that all the PEs in the same Ethernet segment will agree on the same split horizon type. And if they disagree, they fall back to the default type. What have we added in the new revision in 02? We added SRv6 support. So in SRv6, if you look at the SRv6 services draft, the split horizon filtering is based on something equivalent to the ESI label that goes into the argument of the SID. The idea is that obviously it's an IP encapsulation, so you have the choice of using local bias, and in some cases you may want to do that because you want to save some, extra lookup on the argument of the SID. So that's why we added this. We also fixed some small things and typos. And basically what we want next is to request a working group adoption, of course, to get more feedback. And but yeah, we think the document is ready for working group adoption. Any questions?
Who has read the document? Okay, thank you.
Thanks.
Luc-André.
Good afternoon. I'll be presenting a a draft covering EVP and VPWS seamless integration with legacy VPWS on behalf of my co-authors. So just to give some background information, RFC 8560 addresses the seamless integration of EVPN with VPLS. It has some exclusions, some gaps, so it does not apply, obviously, by definition to VPWS. And explicitly in that draft, in section 2.6, the interoperability of VPLS with EVPN for all active load balancing mode is excluded. So a second item of background, there is another draft. It's an ID. Addressing essentially the EVPN integration with VPLS in all active mode. So this is so that draft was written specifically to address the gap, the all active gap that I list in the second bullet of 8560. And so there remains essentially the first bullet, the gap for VPWS. And the goal of this draft is to address, sorry, that EVP and VPWS interop for both LDP and BGP AD. So the solution we're presenting, we define essentially a hybrid PE. So this is a PE that supports both EVPN and legacy VPWS. And we define then also a legacy PE. So these are PEs that we are trying to interoperate with that support only LDP and BGP AD. So as part of this solution, essentially the hybrid PE, so this is the EVPN capable PE, advertises in a discovery phase, advertises both all EVPN routes and LDP and BGP AD endpoint information that it knows of locally. And then obviously this hybrid PE is going to be capable to receive and process the remote information discovered from all of the remote legacy PEs, obviously also the EVPN PEs. So the idea behind this draft is that all of the logic for seamless integration resides on the hybrid PEs. So the underlying principle is that the legacy PE, so basically in blue here, requires essentially as close to zero touch as possible. And we define in this draft then basically very similar to 8560, a preference of VPWS over the legacy sudoers, be it LDP or BGP AD, for bringing up sessions. And as part of that, then the legacy sudoer that matches this new EVP and VPWS segment is kept admin down or operationally down. So how does the migration from legacy to EVPN, VPWS, or even FXC happen? Essentially, it's as straightforward as you would expect. From a starting point of two legacy or two PEs that support only legacy pseudo-Rs, LDP or BGP-AD, we then go to a PE1 that now is a hybrid PE, supports DVPN AFI. And as such, when you configure VPN on this on this hybrid PE, in addition to the LDP or BGP-AD routes, then the EVPN routes are going to be advertised. And that's represented here essentially in green. After that, as part of basically the final stage of the migration, the PE2 then enables the EVPN AFI. And since EVPN is preferred in this case, the legacy pseudo-R in blue is brought admin down, which will result in either label withdrawals or pseudo-R status down, or status TLV, I think, in BGP-AD. And essentially now the unconfig of the legacy pseudo-R is possible. As far as multi-homing goes, so I won't go into, the draft actually addresses the full set of EVPN load balancing, single active, port active, and all active. I think really the only interesting use case that I'm going to present today is all active, because single active and port active are actually quite straightforward. So for all active, sorry, for a P3 running pseudo-R redundancy, so represented here in the solid blue line and the dotted blue line, PE2 can actually leverage the existence of this blue dotted line to forward traffic in the left to right direction, so from the CE into the core. The only caveat is obviously the reverse path traffic. So PE3 being a legacy PE will only be sending the traffic over the active pseudo-R. There is one small caveat or one small gotcha to the scheme I described before. So if you look back, essentially on the right side at PE3, there's a red flow that's arriving on the backup pseudo-R at PE3. If P3 doesn't actually support this position on that backup pseudo-R, and we have seen implementations that do not, this draft then presents essentially a scheme to mimic that asymmetric forwarding from the previous slide by essentially having PE1, who's EVPN aware and has an active pseudo-R and an active session to PE3, have PE1 share what we called essentially an alias pseudo-R label over to PE2 to share the session between PE1 and PE3 with PE2 in such a way that PE2 can then use the P3 next up and the P3 label for sending the left to right CE to core traffic. And that's it.
Jorge Rodan, Nokia. Yeah, so it would be good to have some feedback on the mailing list about these two solutions. For me, I also know at least two implementations of different vendors that support, receiving traffic on the backup pseudo-wire label. So, obviously, if there are some implementations and there are some standard documents that say that you shouldn't do that for some reason, obviously we need to look at the other solution. But if this is a perfectly good solution and is widely supported, it actually solves the issue in a very elegant way and also avoids some of the issues of the other solution. In the other solution, you actually get traffic from two different nodes with the same label, and that can actually bring up a lot of potential issues. And besides, you have things like stats, QoS, and stuff like that on a pseudo-wire basis, and all that is broken with that model. So it would be nice to get feedback on the mailing list.
Sure.
Thanks.
This is Wen from Juniper. I have the same comments regarding support P3 active backup, like using aliasing label for point-to-point pseudo-while. I do not think it's a protocol limitation to have two different pseudo-while from P3's perspective to using both P1 and P2 if you want to do the active standby P1 and P2. So I feel like we probably shouldn't burden with the standard protocol to add aliasing label for point-to-point pseudo-while. So same,
Sure.
yes, yeah, thanks.
Hi, Bo from Huawei. I have a comment that should we consider whether to support money homing PE is different. One is legacy and another is hybrid.
Is what, sorry?
One is one money homing PE, one is legacy PW, and another is hybrid.
So you mean P1 hybrid and PE2 legacy?
Yeah.
We did not address that.
Okay. Also, I think that can you describe it whether we should consider it or not? Okay.
Okay. I'll take a note. Thank you.
When you should be the next one?
Hello, my name is Wen. My name is Wen. I'm from Juniper. Today, I'm going to talk about EVPN and BGP-based layer 2 VPN seamless integration on behalf of the course on the list here. So agenda for this presentation is first we're going to cover seamless integration for point-to-point VPWS pseudo-while between EVPN, VPWS, and BGP-based pseudo-while. And we're going to cover how to support single home, the seamless integration, port active, single active, and all active. And the second agenda is talk about the extension to the existing EVPN, VPWS, multi-point to multi-point seamless integration is extension. Current IFC does not cover the hybrid or the composite PE CE doing active multi-homing. So this is just extension to the existing IFC for active support. So BGP-based layer 2 VPN support different type of payload. For when we talk about seamless integration, it is for the payload is Ethernet frame. So just want to make this clear. It's just for Ethernet payload. And so on here you see a Legacy PE layer 2 VPN, and as the blue one, I call it a composite PE. Basically, they support both the control plane signaling for BGP-based layer 2 VPN and also EVPN, VPWS layer 2 VPN. So the key to do the seamless integration is three things. If we have legacy VPWS running, when we're doing the seamless integration, there's no update. Definitely cannot update legacy PEs running in the system. And but for the composite PE, they will run both control plane signaling process. Whether it is so for the backward compatibility, they run BGP-based layer 2 VPN, control plane signaling, and also at the same time run EVPN, VPW-based signaling. No change to the control plane protocol on both sides. The hybrid PE need to do the both. And so it's always backward compatibility. If there is a legacy PE, we will establish pseudo-while with the traditional VPWS control plane, data plane procedures. If the other side running EVPN, so EVPN only take a high preference, the pseudo-while VPWS will be established with EVPN VPWS. So basically just 3 points. never upgrade, no upgrade for the legacy PE, and composite or hybrid PE will always do both control plane signaling. And if both support, it's a EVPN take preference. So that's this is explain like in the situation in the what is done in the control plan, what is done in the forwarding plan. Forwarding plan is always the same, but control plan we need to run both protocol in the composite PE. So for support seamless integration on the composite PEs, we do support active, standby, or port active. Basically, what's the difference between active standby and a port active is how CE is connected to the multi-home PE. In port active, they are using the lag interface. So this is a help customer or the service provider if they are doing the migration one metro Ethernet at a time. So they migrate one region at a time, but after they, you know, because one side, when it has not upgraded, they are doing the traditional VPWS. But when the first side is migrated, they can just upgrade the CE to do the lag. They do not have to do a second migration to upgrade the CE from a separate physical interface to a lag interface. So this is a shorten the migration cycle, right? So this helps. And it can also go directly to the active, but in the active case, since the legacy PE, layer 2 VPN PE, they do not know how to do active. They only support active standby. So traffic from the legacy PE to the composite PE is only, it will only choose the DF to forward the traffic. Versus the composite PE, they do active. So we have a asymmetric forwarding going on here. So it's showing here, but it's possible. It's just also saved one phase of migration. The composite PE can go directly to active. So the other topic gonna cover in this talk is active support for point-to-multipoint pseudo-wire. So the challenge for that traditionally is VPLS only can support active standby. There's a couple challenge for that. VPLS does not like EVPN. They have a label indicate this is a bound traffic. They do not support split horizon, right? So that's a trouble from point of bound traffic perspective. But with seamless integration, we do have advantage because the composite PE, they are running EVPN, okay? They understand EVPN, they do EVPN procedures. So this help us overcome the limitation in the VPLS cannot do bomb traffic, like a support bomb, like how to avoid a looping or duplicate traffic. So the composite PE, they can using the EVPN process, since in the hybrid or composite PE, they share the same MAC forwarding table, so they can use in the EVPN procedure, the ESI label, everything, like it just no change, just the existing EVPN process to overcome the VPS limitation. One is layer 2 looping for the bomb traffic. The second is duplicated bomb traffic. So this problem is solved over a bomb. So what else is the challenge to run active, while the other side is the VPLS, is MAC flip-flopping, because the CE is connected to the composite PE using the lag interface. So depending on the hash algorithm, the same MAC can be data plan learned on a PE1 and a PE2. So VPS PE can learn the same MAC on both pseudo-wire. So this is another challenge to support the VPLS active. But there is one very common procedure is called pseudo-wire MAC pinning. With that, we can pin this MAC, even though in the core it's data plan learning for VPLS, we can pin the MAC to one particular PE, whichever it comes first. and that particular MAC will be always ping to one of the PE. Let's say it's first is coming from PE2. So VPLS will think CE1's MAC is always accessed by the PE2. Even though later on I learned the MAC from PE1, it will, due to the MAC pinning on the pseudo-while feature, they will never have a flip-flop for MAC pinning going back and forth. Of course, in order to do this, let's say PE2 is a non-DF, right, supposedly. So how are we going to make sure VPLS forward traffic to the PE2? So this is also existing control plan protocol help us solve the problem, because we can advertise VEID PE with this two PE, even though they multi-home to CE1, they can advertise two different VEID, called the instance VEID. So this way, both PE1 and PE2 can extract the unicast, non-unicast traffic. So depending on whichever VPSPs, how they learn the MAC. So the traffic for both non-unicast and BOM traffic are symmetric in this. And the advantage for that, it does not need any forwarding plan change. Basically, we pretty much can use existing feature for VPLS and the seamless EVP and VPLS integration. So the other last one is what happens if the node failure, access link failure. We need to flush the VPSP to have it rerun the same CE1's MAC. So this is triggered through MAC flush mechanism. Like for VPS, we have this forwarding bit. When it changes from 1 to 0, signal to the VPLSP, they will automatically flush the MAC so they can relearn the MAC. Say before it learn from P2, if CE1 P2's link fail, they can relearn the MAC from P1. So this overcome, it's just used the control plan process to its advantage for VPSP and support active for VPSP. So that's all. So like I think the VPWS point-to-point, as I mentioned in the beginning, it's the three things for backward compatibility. We cannot upgrade legacy PE. We need to do the backward compatibility, and the EVP and VPWS always take precedence. So this three principle can be applied to most of the traditional point-to-point pseudo-while to EVP and VPWS seamless integration. And so like to seek comments, and if it's needed, we can, even though this right now, the draft first version only covered the layer 2 based VPWS to EVP and VPWS seamless integration, but the principle is the same for point-to-point. Yeah.
Hi, Wen. Le Condré Cisco. So I do have some comments on this draft, but
Sure.
I'm going to keep it short here to 4 comments. So the first is a preface to the chairs in the working group. So we are aware there's complementary drafts trying to address essentially a very similar problem, and we have discussed the need for a unified approach. So when this draft, it addresses basically only BGP-AD, not LDP. So, and I think we've spoken about this before. I think it's, you've mentioned it's specifically meant to be BGP to BGP, basically. But the approach of ignoring LDP, I think, makes it a little bit incomplete in terms of interop. So my second point is, I wouldn't address VPLS all active in this draft. So in my mind, keeping VPWS and VPLS separate seems like a better classification. So as a side note, the MAC pinning you described for VPLS, that's actually not part of 6624, and it's not as prevalent or as standard as you would imagine. So I think if the VPLS stays in this draft or a common draft, I think we'd have to add essentially support for the MAC pinning into a requirement of the VPLS solution, because I think the MAC pitting makes it a little bit inoperable for some vendors. And lastly, in the draft itself, so you haven't really spoken to it here, but in the draft itself, you mentioned, and we've discussed about this, so I'm not too worried. In order to find a match for interop, you discuss how the EVPN ACID on the EVI route, on the EVI EAD route, and the BGP-AD VEID need to match in order to set up that interop?
No, that's not true, because as I said, like for composite PE, they are just execute BGP-based control plane signaling, and also EVPN, VPWS as control plane signaling. They are totally independent. This is as I show up in this diagram here, at the little circle here. This is the control plane. They just totally independent. They just advertise their own control plane signaling, and how this is configured, whether they use the same VEID or BPW instance ID, it's really the provisioning. It's how you provision this. It's implementation dependent, whether you want to do. But there are two separate control plane entities for the hybrid composite PE. Only in the forwarding, there's only one. They have to either go with the traditional way to establish the pseudo-wide, basically in really what's matter is the label, right?
Okay, perfect. No, I think we're in agreement on that.
Yes,
then,
yeah. So if if it's I can edit the text if there's a confusing. I did not make clear in the text, but the intention is it's really implementation dependent for the provisioning model you use. Yeah, I'm not in emphasis on one the other. Regarding the VPWS, yeah, I agree. There is a different way to do it. There is a forwarding way. There is a control plane way. As we presented it here, I think is lightweighted. It's another way to achieve seamless integration with EVPN, VPWS, active. I agree. There's a different way to achieve that. So.
Hi, Bo from Huawei. Now for this page, it says that we may use MAC pinning to avoid flip-flop. Yeah. So I think perhaps we may consider other. Perhaps it may have a better method to resolve it. I don't know, but I think we may discuss about this.
We can sure discuss offline. There's other option. I definitely not exclude as option. This is just one option, as I said before. Yeah, okay. And we think it's lightweighted because it does not involve forwarding change.
Yeah. And another question, comment is that for some scenario, the VPLPE perhaps it may use the PW redundancy before. So I think that perhaps we missed the scenario that one VPLPE use PW redundancy. What's about the traffic and the control plan?
I didn't get this point. Could you repeat again? VPSP using
PW redundancy. For some vendors, some operators, their scenario, their VPLPE have used PW redundancy before. Yeah, pseudo redundancy.
It's active standby, right? For VPS.
Active standby. So for this, I think we may consider that what about this scenario?
Okay, so I assume I assume seamless VPS integration. The existing IFC covers active standby. That's why I did not here. This is only an extension to what it has not covered in the existing IFC. So I did not repeat if VPWS is doing active standby. We should support.
Yeah, but I think that we may consider that when VPLP use active standby pseudo redundancy, but why we want the C side, the money homing side use money active, how to do? I think we may consider that.
So you mean why we want to support active?
Yeah.
Because if ultimate goal for the service provider is to provide active service, right? So they can save one migration phase, because otherwise they have to wait until all the Ps in the network to be upgraded to the hybrid or composite PE, then they can support active. Here, when you upgrade P1 and P2, they can just go right to the active CE lag interface, and PE1 active. When they upgrade the VPLS PE, which may be in another metro area, they do not need to go back to the first metro to say, all right, now the second metro area also do EVPN. Let me go back there, touch their configuration, another qualification required, right? So that's the main purpose if the ultimate goal is to support active.
Yes,
Okay,
I
no,
know.
could you just continue
Okay.
this discussion on the list? I will just let Jorge do a very short comment, if you are very, very short.
Okay.
Yeah, we can offline if you still have questions. Yeah.
Yeah, Jorge, I'm very short. I just wanted to highlight that with this MAC pinning solution, you also get load balancing on the right to left direction, right? Because if you have multiple Macs behind CE1, some Macs will be pinned to one to the wire and other Macs to the other to the wire. So it's actually a very simple and efficient solution.
Yeah.
Thanks.
Thank you. Yeah, thank you. Okay.
Okay, thank you. Who has read both of the documents? Okay, I will really encourage the working group to read both of them because we need to find a single solution. So you need to find an agreement, and I would and I think my co-chair is also agreeing with what Luc-André has said. VPLS and VPWS, we can address them in two different documents.
Yeah, we can talk offline to see what's the progress.
Do you see a value, Jorge, of having a single one?
There is other option, which is to write an 8560 BESS and basically fill all the gaps that we have with seamless integration, including VPLS and VPWS. That's another option. I don't have
That's
a
another
opinion,
option,
but,
yeah, of course.
But that's
if we can avoid also, yeah. But we can discuss this offline. Thank you.
Thank
you. Jorge, just coming back to your point, regarding the pure VPLS integration RFC, do you see any missing point apart from this active-active or any errors that we could have in this RFC that could also justify a respin?
No, I mean, the main thing is all active. That's the main gap. And I heard in the past some of the paragraphs and text can be clarified. So we could also take the opportunity to.
Yeah, if you can just give us a full picture of what could be improved, maybe we can justify a respin.
Okay. But again, I don't have a strong opinion. If people prefer to have two separate documents, that's okay too.
Yeah, so for point-to-point, unlike point-to-multi-point, they do not have a concern complexity for dealing with the bomb traffic looping or the duplicated bomb traffic. For point-to-point service, no matter what type of, like say, point-to-point service it is, it's pretty much the same. You have to support backward compatibility, and EVPN always take precedence if both types of signaling is there. So it's much.
We need to switch to the other topic. Sorry.
Yeah. All right. So yeah. So here is a just quick update for the extended optimized ingress replication for EVPN. We presented like maybe 2 IETF back. Okay. So what has changed? There is no change on the draft front, and Juniper has implemented this feature and has shipped in the early part of this year. And just a quick summarize for this feature. This feature is based upon the optimized ingress replication. So it inherent all the good benefit for the optimized ingress replication. Use a diagram leaf spine topology. For example, I only draw one spine here. You could have a many more spine, and you can do load balancing. But just for simplicity, illustrate the benefit it has is say on a leaf one have a receiver. For example, receive a multicast flow and need to send to all the leaf. Just presumably behind all the leaf, there's an interesting listener. So without the optimized ingress replication for EVPN, the leaf one would send 6 copies of the same multicast flow to the spine. With the optimized ingress replication, they only need to send one copy, and then the replicator, which is a spine, they replicate the traffic to the rest of AR leaf, assistant replication leaves. Okay, So and also bandwidth saving, uplink bandwidth saving, and also alleviate the burden of AI leaf to replicate our traffic. Imagine you have and the leaf is over 200, 300. You have to replicate so many copies, right? So this is a definite benefit for optimized ingress replication. But in order to, on top of that, in order to support multi-homing, which is a very common case in the leaf, because during the assistant replication, the replicator has to decapsulate the packets and then encapsulate the packets again. So in order to support multi-homing, you have to, whether it's a VXLAN or EVPN MPLS, in case we want to do ESI. In case for some reason people still want to using ESI label, split horizon label for multi-homing support, so this require assistant replicator to retain the AI leaf once IP address or the split horizon label. So this is a very much complicated AI replicate function implementation, even if it's doable. Some commercial chipset is not even achievable. So this extended solution is to address the multi-home scenario. So extended AI leaf is using the regular normal standard procedure to replicate the traffic to its peer multi-home P. The rest still doing the goes to the leaf to spine to do the replication. So that's just a quick summarization, and so we would like to seek the working group adoption. If there's any comments, we will address. So,
okay, who has read the document? Who thinks it could be ready? Okay, so
I have a question.
yeah, go ahead.
Okay. This is directed to the chairs. Is the goal of these drafts for interworking to be IPR free, or is that a non-goal?
I missed your point. Can you say it again?
Certainly. Are you looking for an IPR free solution, or is that a non-goal?
Do we care? I don't know, honestly.
Wow, you're short, Wen. Okay, there is no yang in this presentation. And despite the E of enhance, there's no EVPN. What we're looking at here is an idea for defining something we call a BGP-LS filter to offer a way of building a control plane for enhanced VPNs and network slicing. So what is this stuff we're talking about? Well, there's a working group draft in TEAS describing enhanced VPNs, and essentially they are VPNs with a little bit more required by the user to, sorry, I'm just fight this so I can stand up. Yes. The user requires a little bit more from the VPN in terms of latency, delay, jitter, resiliency requirements. So it looks otherwise like a VPN, and so it's natural to build on the VPN technologies. And what we're trying to do is manage the underlay to to provide those VPN services. So our approach is a generalization of SRT policy, supporting all the good connectivity types, and integrating with BGP VPN, and kind of building the quality behaviors on top of coloring mechanisms. So the approach requires some kind of centralized view, as RTE does, so that you can do the optimizations in a central controller and take as information to that the traffic matrix for the VPNs, the properties that are required by the VPN, and the information about what's there in the network already, which you would get out using BGP-LS. Given that, the network controller can have a look at what's available and make some decisions, and assign to the P routers bandwidth that will be identified or associated with DSCP code points or adjacency SIDs. Having done that, each enhanced VPN gets a subset of these underlay resources, and that subset we are calling a BGP-LS filter. So BGP-LS presents the whole topology. You can then filter that topology into a set of resources that are assigned to a VPN. The PEs have a complete view of the underlay, of course, but they're also told about the BGP-LS filter, and so they have a filter on that underlay. And we encode that with a new attribute and push it southbound to the PEs. You can apply this in all sorts of granularities, so you could do it for all PEs in a single VPN, or a set of PEs in a VPN, or an individual PE. Otherwise, it's kind of like standard VPN tools, using pushing the BGP-LS filter around with BGP. So we think that this the BGP-LS filter integrates really easily with the existing VPN support, and that's what we really want, because we want to move incrementally from existing VPNs into enhanced VPNs. We want to be able to support inter-AS, we want to support the IGPs, and don't want to have to do significant new invention, I think largely because we're lazy. We get everything of the traditional VPN scaling out of this, so that the per VPN information is kept out of the core, and non-enhanced VPNs just don't get this filter information and just go on operating as usual, and sharing resources in the core. So the key to this is the BGP-LS filter, providing a view of the connectivity between the PEs for a particular VPN or for a set of VPNs. And that's where we sort of come into slicing. In the concept of slicing, you're partitioning the core resources and using them for a class of services, which may be multiple VPNs. You need multiple paths between PEs to give resiliency and to give maybe different qualities of service. We're tagging the filter with the RTs of the VPNs for the PEs that support it, so that makes the import work. And then when you send a packet, you select the path to the egress PE from that LS filter. You add the segment routing information into the header, or place the packet onto the right LSP, depending on what your forwarding plane is. And you can use any computation tool or engine that you want for that. The underlay network may appear, pieces of the underlay network may appear in multiple BGP-LS filters, and that's all according to what the central controller has done, how it's looked at the resources. But it means that you need an AFI and a SAFI with different RDs for each filter. So we need a new BGP-LS attribute. So here's just a pictorial thing. Base topology, you might split it into different filters according to what connectivity you want and what the core network is able to produce and deliver for you. I think you see this picture in virtual networking and all sorts of different ways of slicing core resources. Shouldn't be a new idea. The filter attribute, we assume that a PE may support multiple BGP-LS filters, so it can be in all sorts of different, one PE can give access to multiple VPNs of different types, and the filter may change over time as nodes get added or removed, and as the core changes. The way we've defined it is that the BGP-LS filter may contain multiple updates, and that those updates may arrive in any order, and that they may get interleaved. So that's just, this is the assumption that there is no assumption, I guess. So this requires that we have a filter identifier and a version number and a filter type and a number of fragments and an identifier of the current fragment. That's sort of business as usual. And then you can also include a code point in there to indicate what DSCP code point you would use for packets in that filter. You can't actually use the BGP-LS filter until it's fully established, so that's why you need to know how many fragments are coming, and you can only use a network resource, guess what, if it's active. You can interrupt me or you can, okay. The underlay topology is, in a sense, the union of all BGP-LS filters, plus, I guess, anything that the central controller has held back for rainy days. Yeah, I won't say anything more about that, I think. So
you have to close soon if you want to have questions.
Last slide.
Thank you.
We're going to check back with the framework to make sure we're actually addressing the right thing. There are a number of data plane and control plane drafts out there for enhanced VPN. We've been meeting with those authors already this week, and we think we're aligned, but we need to do some iteration on the draft. Sue.
This may be orthogonal to you, but just curiosity, you've talked a lot about filters and you've talked a lot about the attribute. Could you first provide me a very specific description of what you mean by attribute? There are a lot of BGP attributes. I assumed you meant a BGP-LS attribute within all the components attributes. Am I correct in my assumption? Second, will you be combining this with FlowSpec?
So in answer to your first question, yes, BGP-LS attribute. Sorry, I was sloppy. In answer to your second question, maybe.
It seems like a natural case, in which case I have some other concerns, but you need to determine whether you're going to do the maybe or not before I bore the
Yeah.
rest of the world with the concerns.
Early days for thinking about that, but thank you for raising it, and we will huddle and
Okay.
try to work out what we're doing.
The reason is, if you missed the BGP meeting on Monday, we will be doing L2 version 2 of FlowSpec. I think that was what the operators have. So if you're going into that area, please do expeditiously consider your brain trust and go on.
Hi, Ketan Talaulikar, Cisco. So BGP-LS as we have today is a northbound thing. So going from the network nodes to a controller. And I believe in this proposal, what you're looking for is a southbound. It's like a provisioning kind of a thing. So
Yeah,
I
no,
would suggest I would suggest if we could consider having a separate AFI-SAFI. We could still use a lot of the TLVs, code points, and everything defined for BGP-LS. We have another AFI-SAFI defined for using the same in LSVR. So I would recommend, if it's possible, to not mix it up with BGP-LS and have a separate. I mean, something like SR policy SAFI, for example.
Yeah, you're probably right. I need to think.
Just an input. Yeah.
Stefan Nitzkowski speaking as individual. So it's really similar to a multi-topology framework that you want to build, and you want to push topologies to nodes and then reclassify on each node to find the right topology you need to forward on.
Yeah, it's very similar. I'm shying away from multi-topology because that's not necessarily going to scale to the order that we want. But the concept's similar. Yeah.
Okay. So do you confirm that on each node you need to, for example, look at the DSCP to find out on which topology you need to flood, or is it always leveraging on segment routing so the ingress is pushing everything?
So only the edge nodes are seeing this stuff. Right, this is VPN behavior. The core nodes have to know how to forward based on, if they're using SR, they need to know how to forward SR. If they're using DSCP, they need to know how to forward on that. But that should be business as usual.
Okay. And my last comment, and I think I already did this comment by email to you, I'm really worried about this version number which is tied to the full topology. So each time you have a topology event, you have to push back everything. So you're slowing down the convergence time compared to having a sequence number on each piece of your topology.
Yes, and I probably glossed over it too much, but the fact that we can fragment the messages that we can push down means we can do updates.
Okay.
I'm going to cut the line off after Jeff.
Wim Hendricks, Nokia. So the goal here is to distribute, let's say separate topologies in dedicated VPNs in a distributed manner in order to do distributed TE kind of use case, right?
Yeah.
So the question I have is, given that you get from a controller, you push it back down, how are you going to do bandwidth-based use cases? Like with using segment routing?
So what's pushed down is your
yes, but so
it's
in
a
order to
topology
do,
that is your bandwidth to do with as you like.
And you cannot share it?
That's right. You have no one to share it with.
Okay, but sometimes certain links can be shared between different
yeah,
VPN
so,
topologies. So is this solution basically saying you have really dedicated infrastructure only for that VPN?
No, I think you can do both.
So yes, okay, but then if you do bandwidth use case, right?
So no.
And bandwidth is excluded?
No, so cut that if. The controller has looked at the link and said the link has got this much bandwidth. Sure. I partition that bandwidth and I give that link with only a smidgen of bandwidth to you, and I give the same link with a different piece of the total bandwidth to somebody else. And they are operating, they believe that they own that link with that little bit of bandwidth.
And only that bandwidth is available to that VPN?
To that person, yes.
And it cannot be shared?
It can't be shared with that bandwidth that has been given to them can't be
And
shared.
how are you
yes.
going to, in a distributed way, figure out that link which is used by multiple PEs, how are they going to relate the bandwidth for all these, the same VPN going to the same link, which is shared for that topology? How are you going to do that in a distributed manner? With segment routing?
Well, segment.
So you need a controller.
Well, you have to go to a controller, but it's a controller for that slice, not a controller for the whole
Yes, but
network.
what I'm trying to say is that you distribute the information to
We are a bit
distributed
out of time. We are
to
really out of
distributed
time.
TE, but you actually need a controller to do the bandwidth. So there is a problem in this solution.
You should go really, really fast with the two last comments because, yeah, the last speaker has just 5 minutes.
Okay. In fact, we touched on from China Mobile. In fact, he have asked the most of my question.
Yes,
The other
just
question,
state your name.
Yeah, is that for operator, how can we use this function? What it can provide?
So what an operator can sell if they have this service is they can sell a VPN to an enterprise where that VPN has got additional service level commitments like latency, like resiliency. Or the operator can sell a service to another division of the operator, for example, a wireless division, as a slice.
What's the difference between this way and the current VPN?
The current VPN is a connectivity service offering bandwidth. End of story.
Please continue this discussion offline. Yeah, really fast.
Yeah, two short comments. One, I would question DCP forwarding at all. Using caller gives you association between next hop, caller, and then recursive lookup, which makes it straightforward and easy. Lack of feedback in BGP is a problem in general. I would like to see how you would address it, because you create an intended state, but then you don't know whether resources actually have been allocated and operational state. So you're stuck with BGP. You can only withdraw, right? There's nothing in between.
So I'm not sure I'm getting that, but we should huddle afterwards.
The difference between your intended state, so what you're trying to configure, and operational state should be retrieved somehow, and BGP doesn't give you that.
Yes, it doesn't.
Thank you, Adrian. Satya? In theory, you have just 3 minutes remaining before the end of the meeting, but I think that there should be a break.
Mine should be short presentation anyway.
Okay,
so.
cool.
Okay. Yeah, so hi, I am Satya Mohanty from Cisco, and this is on behalf of all my co-authors. So this one we presented 2-3 IETFs ago, and there was some discussion, so we incorporated that feedback. So this, yeah. So this is some related eVPN multicast work. I just put them, which I thought was important for this. So the first one is the IGMP MLD proxy. I believe it's going for working group last call. So, and the second one is the per multicast flow DF election. These two drafts together probably account for 85 to 90% of the multicast cases for the eVPN. The last two, one is the optimized ingress replication in NVO networks, and the other one is the bump procedure update drafts. So this draft is relevant for the remaining cases, which is like the bump traffic in using ingress replication, then bridge domains with no IGMP, MLD, PIM proxy, and the other one is the BDs with no OISM or IRBs, and most of it is taken from the feedback that was discussed in, I think, in after London IETF. So one of the other things that was told to us is to make it informational, because it did not be a standard. So we made it an informational draft. So the main thing here is, as you can see, there are 2 redundancy Ps, but in some cases we have seen up to 4. So the main idea is you don't need to send multicast traffic to people who do not need it, right? So in this case, as I've shown here, this P2 and P4, they are the designated forwarder and the non-designated forwarder, and the others P1 and P3, assuming the conditions that I showed in the previous slide, they exist or they hold, then we don't need to give them the multicast traffic. So that's what I've shown. And last time when we presented, the use case was from a DCI perspective, but the draft mentioned about PEs and CEs. So to clarify that, I have put 2 slides. So as you can see, the solution is very generic. It's like it can either qualify for PEs or DCI. It doesn't really matter. Okay. So this I already said that DCI 2 and DCI 4, they only need to send their inclusive multicast routes. So one thing here is, this is from the framework RFC. So what it says is, if we have a set of CEs that are multi-home to the same set of PEs, then to get good entropy, we need for load balancing purposes, right? What we do is we take the ES into consideration inside that HRW hash function so as to get a good spread. And some of this, the English is written by John. So, but for this one, for this particular case, we do not really want the ES to creep into the equation. Why? Because we want for both the ES1 and ES2, the DF should be unequivocally the same same DF, same DCI, which means that we can set the ES to 0, and then irrespective of the ES, they will all map to the same DCI or the PE. So that's one thing I think I missed writing that in the draft, but in the next version we'll do it. And that can be done probably by a knob. And I think that's it. The inter-AS case is already covered, so we don't have to go into that. Yeah, that's my presentation.
Any comments? Okay, so this is the end. Thank you, and see you in Vancouver.
Have the blue sheets anywhere, please.
Yeah. Okay. I have sometimes some issue to follow all this web traffic. It's really complex.